We are discussing solutions for LeetCode Weekly Contest 390. Jump to specific questions using timestamps in the video description. And please check out the rest of my channel if you enjoy LeetCode contests. Like and subscribe. Okay, so this week's question 1 and 2, especially question 1. Oh my god, this is way harder than it should be. It's still not that hard, all things considered, but it's harder than it should be. Question 2 is quite easy, I think, if you know the trick. Question 3 is annoying, and question 4, I think it's doable. You need a prefix tree. But we will go through all 4 questions one by one. So let's start with question 1. Question 1 is maximum length substring with 2 occurrences. Given the string S, return the maximum length of a substring such that it contains at most 2 occurrences of each character. So for instance, this is the input BC, BBB, CBA. Let me CBA. The longest substring, which at most 2 characters, is this one, BCBA, and it has a length of 4. And then in the second example, AAAA, the longest substring that contains at most 2 of any character is AA, right? There are 2 A's here, and this one has 2 B's. So you can't not have more than 2 of any one character. Please explain the problem 1 statement. Yeah. Okay. So basically, you want to find the longest substring inside the S, where the substring does not have more than 2 of the same character. So this substring has 2 B's. If it has 1 more B, it will fail. So you can have up to 2 of any character. So likewise, this has 2 A's. If you add 1 more A, it will fail. Right? This one you can add another C if you want. You can add another A if you want. Okay. So this question is actually it's super hard for a question 1. I'm not gonna lie, right? But in the grand scheme of things, it's not difficult. There are a few ways you can do this. I'm gonna go through the way that I did it first. So the way I did it is by brute force. I use a nested for loop. I have I, which is a start. It goes from 0 to the end of the string. And I have J, which goes from I plus 1 to the end of the string. Okay? And the idea, this should be like this, I think. So the idea is then, inside this nested for loop, I get the substring. So the substring, depending on what language you code in Python, is just substr. It's just like SI:J. And then what I do after that is I count. I want to count how many times each character appears. So the first step is generate all the possible substrings. So BC, BCB, BCBB, CBBB, B, whatever. So the number of substrings is n squared. And inside those n squared substrings, for each substring, I count the number of times every character appears. And I make sure they're not more than 2. Okay? Yeah. So the way I actually did it in Python, because I use Python. The nice thing about Python and like programming contests, and why I recommend Python is that it has a lot of tricks and tools. I actually recommend Python if you're doing tech interviews also. If you're doing a lot of interviews, you're interviewing for a job, okay, Python is amazing. There's so many small things that can help you become super fast. So in Python, there's this thing called counter. So counter just takes a list of anything, can be a string, can be a dictionary, can be a list, whatever, and it will count for you how many times something occurs in the iterable. So you can have a function, you can call the function most common. You can look up the API for counter to see why I got 0 and 1. Basically, I'm getting the most common element, and then I'm going to check if this most common element, this most common letter, is equal or less than 2. If it is, then I find the longest substring where this occurs. Yeah, I find the length of the longest substring where this appears, and I return best. So that's it for question 1. Okay, so there's another way to do question 1, which is, and I want to go over this, which is a sliding window. So the way to do the sliding window is basically you have 2 pointers, L and R. Okay? And what you do is you advance R, you keep advancing R until R is illegal. So for instance here, R is legal, right? I'm not gonna take too much time on this. So it keeps going until it reaches here. It cannot go anymore because the next one is B. It's gonna be illegal. Okay? So it does this, and then this will be your best. Your best will be 3. Okay? And then when you've done that, you move the L 1, and then you advance R again until you cannot advance. So this will be also 3. And then you keep going. Basically, you keep going. You keep going. And you end up somewhere here where L is here. And then R is going to be here. And then this will be 4. Okay? So this is a sliding window approach. You know, it's not that much harder to write. I just didn't write it because it's easier to just brute force, and brute force works because, so the trick for brute force is you see the length is like 1000 and below, you can do whatever you want. If you see the number of n is like 10 to the power 5, then you cannot even do cannot even do nested loop. So because it's 100, I can just brute force anything I want. So if you do this sliding window is actually O(n). So this one is O(n) cube, which is very inefficient, right? So the sliding window is much better. So Verbal Sharma, I used to work as a software engineer at Google. I don't anymore. So now I actually teach. I teach at a small university. Yeah. Well, I'm not actually a professor. I'm a like adjunct lecturer. The professor requires a PhD. I don't have a PhD, but I do teach a Python class. Okay, question 2. Apply operations to make sum of array greater or equal to k. So you're given an integer k. Initially, nums equals to this. And then you can choose any of the following operations to apply any number of times. Either you pick an element and increase its value by 1, or you duplicate any other elements and add it to an end of array. Now, if you think about it logically, right? You think about it logically. The first operation is to increase element value by 1. The second operation is to copy an element. So should you copy first or increase first? Of course, if you want the number to be as big as possible, you got to increase as many times as you can and then copy it a bunch of times, right? So you want to copy, let's say this is step A and this is step B. You want to do A a bunch of times. You want to increase this value as much as you can before you copy it. Because you copy first, then you get 2 copies of one, and then you increase one of the ones, the other one doesn't get increased. So you want to do A as many times as you can, and then do B a bunch of times, right? That's the strategy. Okay? Yeah. So what does it look like? So let's look at the mathematics behind it. So now we know we have to do the first step a bunch of times, and then we do the second step a bunch of times. So let's look at steps around it. So if I do the first step, let's say 3 times, 1 becomes 2, becomes 3, becomes 4, okay? 3 times, 1, 2, 3, okay? And then I do the second step, 4 becomes 4, 4, so I'm copying, right? And then 4, 4 become 4, 4, 4, okay? So I do the second step, B equals 2 and A equals 3, right? So I basically increase it 3 times and copy it twice. What will be my answer? Mathematically speaking, is 1 plus 3, 1 plus a, times b plus 1. A plus 1 times b plus 1, right? Because you think about it, you increase it a times, the value here will be a plus 1. And then you're going to copy it a bunch of times, right? So the value here is going to be b plus 1 times a plus 1. Yep, does that make sense so far? So so the goal is you want to maximize this while minimizing a plus b. Because your answer is a plus b, right? Your answer equals a plus b, right? You want to minimize this while maximizing this. From mathematics, how do you do that? Well, you solve, right? You basically solve for a and b. You want a and b to be about equal. You know that from probably like high school mathematics. And so your guess would basically be k square root of k minus 1. But because this may not be a whole number, and a and b have to be whole numbers. They have to be integers. You got to be try them a little bit, right? You can be like round up, round down, do whatever you want. Okay, so that's the basic idea. So first step is to understand the problem, that this is a mathematical problem. Find out what the equation is, and then the equation is some kind of square root of k. So this is exactly what I did. So if k equals to 1, return 0, special case. Otherwise, I take the square root of k. And then I try. Because the square root of k is not a whole number, I have to try 3 different cases. Either the square root times square root. I actually don't think this ever happens. It's either this one or this one. Yeah. So it's either this one or this one. So you just try a few different cases and you get it. Yeah. So I either take square root of k plus 1 times square root of k, and if that equals to k, then I return this. If square root of k plus 1 times square root of k plus 1 is equals to k, I return this. I think these are the only 2 cases. Yep. But the main thing is to recognize that this is actually a mathematical problem. Rohan increase time bound. Yeah, Satyam, Raj. The third question hint was helpful. I end up with TLE. Forced my brain to think a lot. Well, that's the whole point, right? Because like I can tell the secret of doing this LeetCode contest, there's no prizes for winning LeetCode contests. There's 0 prizes. Even the guy who finished everything in 8 minutes, 0 prize for him. But you know what's the real prize? If you can get better at LeetCode and you can interview for a job and get the job, that's the real prize. The real prize is what you gain, what you can do with the knowledge. It's not the contest itself. So for all of you who come back week after week, I recognize so many of you. Well, congratulations and good job on coming back. Okay, question 3. Most frequent IDs. The problem involves tracking the frequency of IDs in a collection that change over time. These 2 integer nums and freq of length n. Each is num represent ID, and the corresponding element in freq indicates how many times the ID must be added or removed from collection in each step. When I read this, my brain was like, what the heck is going on? Oh my god, this is so confusing. At least to me. Maybe you guys, your English is better than mine, so maybe it's not confusing to you. But this is so confusing to me. Goodness gracious. So what happens is you have to actually look at the example to see what the heck is going on. This is so confusing to me. But basically, once you look at example, it becomes a lot clearer. Essentially, what's happening is this. You have numbers and you have frequency. And what you do, number is 2, 3, 2, 1, and then frequency is 3, 2, minus 2, or minus 3, 1. Okay? Numbers and, I'll write it better, and frequency. And the idea is at every step, what you do is you add, change color. You want to add this number this number of times. So you need to add, let's say numbers is 2 and frequency is 3, then you're adding 3 copies of 2. So after the first time step, you're sort of, you can think of it as like array or whatever you call it, right? You have 2, 2, 2. After the second time step is 3, 3, 2, 2, 2, because you add 3 2 times, right? The third time step, you remove 3 copies of 2. So remove these 3 copies of 2, you're left with 3, 3. And then the last time step, you add 1 copy of 1, you get 3, 3, 1. Okay? So that's what's happening. So it sounds a bit confusing, but this is essentially what's happening. So this is actually not a good representation. I just drew this to help you understand. The better representation will be a frequency frequency dictionary. Right? So 2 3 times, 2 3 times, 3 2 times. This one, remove 3 copies of 2. Well, none of these are left. I'm only left with 3 2 times. And then 3 2 times, 1 1 times. Okay? So this is what's happening. Okay, so what do we do after this? The thing we need to do is actually to produce the counts of the most frequent element. So the most frequent element for here is 2 and it appears 3 times. This one's most frequent element 3 times. This one most frequent element 2 times. And this one is 2 times. Okay? So this is the answer. 3 3 2 2. Okay? So this is what the question is asking for. If you're confused by the question, don't worry, so am I. And I think so is everybody else. Yeah. We'll track max frequency. Yes. So the sort of tricky part is actually tracking the max frequency. That's the part that is difficult. Because if you do this naively, I tried this initially naively. I just have a frequency table. What you do is you need to find the most frequent item, right, at each point. So if you do this naively, this is a finding find most common is ON. And you have to do this a bunch of times. And then this is just going to be like huge. Yeah, this is going to be very, very slow. Okay? So instead what I did, which in the end I still didn't manage to do it. So this is my initial answer. If you see this commented out, this is the naive solution. It's like 5 lines, very easy. And then I thought, oh, you know what? I'm going to use a heap. So what I did is I have a heap. And then what I did is I keep like, basically I keep in the heap the frequency and number. So I keep in this heap, I put this inside a heap. Or I think you guys call it a priority queue. So a PQ. So this, I think it works in theory. But when I run it, I have some bug and I didn't manage to fix it in time. Let me see. I think somebody actually managed to do it, right? Priyanshu actually managed to do it. Yeah, I think some people actually managed to solve question 3 using a priority queue. Insert minus value to heap to pop max. Yeah. So the heap, so Python heap can do min and max. You have, so Sachin, you also solve it. Do you use heap or priority queue? Yeah. So okay. So basically this is how you do it. I have some I'm pretty sure there's some bug here because I was very ambitious. So I started out by using an array instead of a heap because array is faster. And then like I messed up somewhere along the way and it just never allowed me back. So yeah, it sucks. It sucks. Anyway. Yeah, okay. Anyway, question 4. Any question about... Let me just make sure there's no question 3. C++ using priority queue. Yeah. Alex, your question, students watch you live? No, unfortunately, they do not. So I had a student, I had like 2 students that watch me a little bit here and there. But you know, the truth is, not everybody tries as hard as you guys, right? So I'm commending you guys because you guys are very hardworking. You would come out on the weekend and enter contests and practice programming, which is really, really good. Not all of my students do this. I think I had one guy who would come by from now and then. You are Indians. I don't know what that is supposed to mean. Does that mean that you work harder? Yeah, so some of my students, I think only one person does. But we'll see. I'm trying to encourage them. Yeah, I'm trying to encourage them to be more Indian like you guys. You know? But they're Americans. So in America, life is good. So maybe we don't try it as hard. Okay. So question 4. All right. Quick show of hands. Anybody, where do you currently live? I'm based in New York City. So I'm based in New York City, but I sort of travel around. Which part of America? New York City. Oh, you live in Memphis. Oh, nice. So I used to live in Nashville in Tennessee. So it's pretty close to Memphis. I've never been to Memphis before. That's pretty cool. Do you go to school there? Sorry guys, I'm just asking Sai. And Sachin, you're in Denver? Oh wow. Denver, Colorado? Nice. Are you guys going to school there? Doing masters? Okay, very nice, very nice. Yeah. So you know what's the next step after masters is find a job before your H-1B visa runs out. That's the plan, right? That's the plan for everybody. Bachelor's in CS. Nice. Nice. Well, you guys are all on the right track. I do sincerely hope you all the best to all of you. Okay, question 4. Longest common suffix query. You are given 2 arrays of strings, word container and words query. For each word query I, you need to find a string from word container that's the longest common suffix with words query I. If there are 2 or more strings in word container that share the longest suffix, then find the string that is the smallest in length. If 2 or more strings have the same smallest length, find the one that occurred earlier in words container. Okay? So if you read this, the first thing that pops up to you should be a prefix tree. Ah, damn. A prefix tree. Okay? Or I think it's also called a radix tree. I don't remember the right, like... Yeah, prefix tree or radix tree, whatever you call it, right? So radix tree, if you don't know what a radix tree is, it's actually a very, very useful, it's called trie. Yeah, that's a lot of names for it. I think when I learned it, I call it like either radix tree or prefix tree, but I think the trie is the same thing. Yeah, so the idea is basically you want to take these words, you want to find the common suffix, right? So the first thing you notice is, this is a bit like cheat code for programming contests. When you see suffix and you only work with prefix, very simple, right? Just reverse all of them. So my step 1 is actually I just reverse all the words in words container, I reverse all the words in words query, right? I turn suffix into prefix. That makes my life easier. And next step is then to construct a prefix tree. So I'm going to briefly explain what a prefix tree is for people who don't know what it is. I wrote some code that does it. Unfortunately, I didn't manage to finish in time. But I will try to finish it afterwards, after the stream. So essentially, the prefix tree, what it does is it will, essentially what it does is that it's going to arrange these guys into a tree. Okay? So I'm going to take these guys into a tree. So the root of tree is always now. And then there's A. Okay, so it's backwards, right? This is DCBA, DCB, and DCBX. Okay? And I can call these like 0, 1, and 2. So the root of tree is now is nothing. And then since they all begin with D, so under D, I have 0, 1, and 2. And then second item is C, C, C. So it's same thing. C, I only have 1. So 0, 1, and 2. So essentially what you want to do is to encode this in a tree. And then under C, there's A. That's this 0. And then X, which is 2. Okay? So essentially what I did, the way I did it, and you can do it in other ways. And the basic idea is you want to like have the have the prefix, right? You have to basically take the word. Each letter becomes like a branch. And then if you go down this tree, you'll be able to find where you are. And the idea is now, if I want to find everybody who has DC as a suffix, as a prefix, I just go down D and go down C. I see 0, 1, 2. Okay, all these three people have DC as a suffix, as a prefix. So that's the idea here. So this makes it very efficient to sort of search for whether a prefix occurs in a large group of words, large number of words. So this is the idea behind the try. So I actually wrote a try. Yeah, it's this thing here. And then I wrote a find function. So the idea is you find, let's say you want to find DCB, you just go down DC and then B, and then returns all these indices. And then in addition to returning indices, because you want to find words that are not completely, how to say, the longest match, you're not looking for exactly DCB, right? So for instance, for instance DC, like, okay, I'm not explaining myself right. Let me refresh. So basically, you're not looking for an exact prefix. You're looking for the longest prefix, right? So to do that, what you need to do is you have to go down the tree as far as you can. And then before you stop, you have to actually say, okay, I stop here. The longest prefix is this length. Yeah. So that's pretty much it. So I that's where I got to. So I got the prefix tree done. I did some sorting here to find the sort of shortest word with the longest overlap or whatever. I think there's a bug here. I still have not managed to figure it out, but I'm pretty sure with some time I'll be able to fix it. Yeah. So question 4 is actually not hard if you have a prefix tree. But I think one thing that I might try to do next time is to actually prepare these data structures. I don't think there's like a default try for Python, but if there is, time of reversing will be word length times n, which is, oh yeah, you know what? That makes sense. So word length times n. Oh, word length and time. Oh, this is fine. Word length is 5,000, right? Reversing 5,000. Huh. Yeah, that's a good question. Maybe that's not gonna work. Maybe I have to just yeah, maybe you're right. That would be too slow. Maybe I just have to use it as suffix tree, which the idea is the same. Yep. Okay, cool. So let me see. Any other questions or anybody? I'm curious. Anybody managed to do question 4? So verbal, do you manage to do question 4? We in India have a lot of IT jobs. That's why a lot of Indians. Yeah, I went to school with a lot of Indians. I have a lot of friends who are Indians now, and they are software engineers now. So if you have questions actually about Indian colleges, you can actually ask me, and I can ask my friends, and they might know, because many of them are fairly senior engineers now, and they are Indian, so I went through the same process as you guys. Okay. Anyway, so I think that's it. I'm going to try and finish question 4. That's all we have for tonight. Once again, thank you very much. Once again, thank you very much for coming. Great job to everybody for trying. Remember, it's not the prize that you get for completing a question. It's the fact that you're now one step closer to what you want, which is a highly lucrative and in-demand job in the tech sector. How can we connect to you? I'm not ready to give out my personal profile right now, but you can connect to my sort of public persona, which is this Alex does LeetCode at Gmail account. Oh yeah, India is morning. Yeah. Feel free to comment. I read all my comments. You can actually send me messages. I think I see them. I'm not sure if I see them, but if you comment any of my videos, I definitely will reply to you. Yep. All right. Thank you very much, everybody, for tuning in. Really appreciate all of you. I have a doubt. All right. Thanks. Bye-bye.